Hello everyone. In this video today we are going to be talking about finding the least common denominator for given rational expressions. Now, the idea for finding the least common denominator for a rational expression is pretty similar to how we find a least common denominator or a least common multiple of numbers if they're given to us with the prime factorization method. So to start off with, let's take two numbers and see how we can find the least common denominator of two given numbers. So let's say if my two numbers that I'm talking about are 21 and 15, and I need to find the LCM or LCD using prime factorization. As always, because we're doing it with a prime factorization, the very first thing we'll do is we take each one of our numbers, which is the 21 and 15, and break them down into their prime factors. So in this case, we get a 3 times 7 for 21, and for 15, we get a 3 times 5. Now, this is the step which is basically taking your number and breaking it down into prime factors. Now, what is it that we get to keep in our LCM or LCD? Remember, when we are talking about working with the least common denominator, the idea is to keep all the factors that appears in each of your given numbers without repeating anything, without doubling anything, because we want to keep the common ones. So in this case, for the LCD, we have to keep the factors that are common, which I'm going to circle in the green, and to stay away from duplication and to keep the least of the common denominators, not just a common denominator, we keep the smaller of the powers if the powers were shown. In this case, there are no powers shown, which means the power on both of the threes is equal, same as 1, so we get to keep it once. And then we get to keep our 5, and we also have to keep our 7. At this point, when we have all the prime factors for our denominator, we will simply go ahead and multiply, giving us an answer of 105. Now, let's move to the left. The idea is exactly the same when we're looking to find the rational expressions of, the LCD of the rational expressions. The difference now is we may or may not have numbers in it. We may just have variables and expressions. So what I'm going to do is I'm going to go ahead and write down my denominator 1, which is simply a z squared. And then I'm going to go ahead and write down my denominator 2, which is a simple z. And then in this case, the denominators are just one term, so I don't have to worry about factoring them. I don't have to worry about breaking them down into their primes because they're practically already broken down into their prime. So we are good to go with the step of just simply finding our LCD. Remember, in this case, the only factor that we see is a z, so we write it down. And as I said previously, in order to ensure that we're keeping all the factors that show up in all of our denominators, but we're not duplicating, we have to keep the greatest of the power. So we keep the greatest of the power, which happens to be a 2, and that's going to give us the LCD to be a z squared. Now, let's take a look at the second problem. Once again, we have a problem with a rational expression with two denominators. And in this case, again, our denominators are pretty straightforward. They're not going to require us to do any work. The first one is just one term. The second one is a binomial. And what you really would like to do for any denominators that are more than one term, that are binomial or anything or like that, you really need to make sure that you put it in parentheses so you're staying away from confusion. Now, if you were to think about it, r and r minus 3 are not the same thing. They're two completely different terms or one term and a binomial, so they are prime. They don't have anything in common. Sometimes people do get confused by thinking there's a r in the top one and r in the bottom one. However, the first one is a simple r, and the second one is r minus 3, so it's completely different. So if you were to think about it in terms of, let's say, numbers, then in this case, your denominator is a prime number, let's say like a 7, and your denominator 2 is another prime number, hypothetically saying like an 11. And to find the LCD of such denominators, we simply, because they're two primes with nothing in common in between, you simply multiply them, leaving you with the LCD of a 77. We are going to be employing the same idea here. Our two denominators are completely different, which will leave us with a LCD, where we are keeping all the factors. The first factor we're keeping is the r, and then the second factor we are going to be keeping in our LCD is the entire r minus 3. And you simply write it down. Now, a key tip with your LCDs is leave it in its factored form unless the question asks you to do it otherwise, because that way you're able to use it when you're working with your addition and subtraction problem of easily upscaling. Okay, now let's look at this third problem where we have LCD of two fractions or rational expressions. And in this case, your denominators are not as simple. They are in a quadratic form. And remember, that's an equivalent to having a number like the one we had earlier, where you had a 21 and you had a 15, where they needed to be broken down into their primes. So this expression over here is a similar one. This needs to be broken down into its prime. So basically what we need to do, we don't, because we're working with LCD, we're only going to be concerned with the denominator. We need to break them down into their factors. So I will put down the x squared minus 16 in its factored form, which gives me x minus a 4 and x plus a 4. Remember, this is a perfect of, this is difference of two squares formula. So that's what it's going to leave us with. And then when you take the second one, which is a quadratic polynomial, x squared plus a 5x plus 4, you have to break it down into its factors, and the factors for that are going to come out to be a x plus 4 and a x plus 4. Now, if you like, you can write it down as x plus 4 whole squared, but that's a matter of preference. Now, let's see how we're going to work with this to find the denominator. The idea is still the same. Your first denominator, let's write that down. It's two binomials that are different. You write them down. And then your second denominator, and I'm writing it out like that so that way I can see, having it top and bottom helps me out a little visually. So I would write down x plus 4 to the power of 2 because I have the capability of doing that. Now, remember, once you had your each denominator into its broken down into its prime factors, you get to keep the factors in your LCD. In my LCD, when I start going from left to right, the first one that I encounter is a x minus 4. The second denominator does not have that, but I'm going to go ahead and keep it, which will be the x minus 4 factor. The second one I encounter is the x plus 4 here, which is the same thing as the x plus 4 in the second one. Now, it is the same factor. Remember, if I encounter the same factor between my denominators, I get to keep it the greatest time it's come in one denominator, which means I'm going to look at my power. The power for the first one not written is a 1, and the power for the second one written out is your 2. So that's the power I'm going to go ahead and write down. I'm going to go ahead and say I'm keeping it, my factor, which is x plus 4, and I'm going to go ahead and keep it twice as my powers indicated. I'm keeping it the greatest number of time it has come in one denominator. So your LCD for this rational expression comes out to be x minus 4 times x plus 4 whole squared. Thank you for watching.